Welcome everyone to Bridging Classroom and Career, FME Grant Licenses for Academic Innovation. Just before we dive in here, I will introduce us to the Livestorm platform. So if you do have any audio or video issues during the webinar, please click that help button on the bottom left. There's 4 simple steps to take. If you'd like to share your emoji reactions during the webinar, we love to see those. So just use that react button on the bottom middle. And then if you have any questions throughout about the grant program or for our guest presenters as we go along here, please get those into the questions tab. We'll definitely be keeping an eye on those, and we'll have some time at the end to answer those live as well. And then lastly, keep letting us know where you're tuning in from in the chat. All right, our peak of data integration is coming up this May 6th to 8th, Dawn. Super exciting.
I know, and the tickets are going fast, and I've had the opportunity to go through many of the abstracts, and wow, lots of great stuff. And of course, there's many that are talking about all the amazing ways people have used Gen AI with FME, and as just one example. Yeah, it truly is going to be 3 days of disruption. On the product side, we have many big things to share, what we're releasing at the peak, but also where we're going next. So it's really, the world of data has never been so exciting. Yeah.
Today, we are very privileged to be joined by a whole panel of guest speakers. We're going to be introducing 3 different guest speakers as we go throughout here, all educators that take advantage of the grant program. First, we're going to be introducing you to the grant program and a little bit about what we do here at SAFE with offering those grants. Then we'll be taking you through 3 guest speaker segments. And then next, we're going to walk you through how can you apply for a grant as a next step here following this webinar. Then we'll take you through some resources as well as have time at the end for live questions. And I'll hand things over to Dawn for our introduction.
Yeah, thanks, Elizabeth. The grant program truly is one of the exciting things we do at SAFE. We take our charitable license or grant program very seriously. And you can see the 3 types of grants we have. And today we're going to be focusing on how we help institutions, but also students get access to the entire FME platform to help them in their studies or work with data as part of their studies. And yeah, so part of it, of course, is the future of data professionals comes out of many institutions, and we want to make sure that they have the opportunity to work with leading edge tools so that no matter what kind of data they're working with, when they graduate, they're ready for the workforce to just contribute right away. You can see we have, it's hard to believe, 295 universities around the world, and then many more nonprofit companies that use FME. So you can see just some of the logos, and of course, 3 that are going to be here today is University of Massachusetts Amherst, RMIT, and the last one is the University of Wollongong, Australia. So I probably mispronounced some of those, but anyway, and then you can just see some others. So it really is a big program, and we're really excited to support it. Some of the challenges that face education and research, funding, of course. Universities for education often don't have big budgets, but it can be difficult for them to acquire and teach the leading edge tools that they want to, right? And of course, if you're teaching a course and it has a large number of students, that means you need a large number of licenses to support the student population and education material as well. So if you're online, and we also provide modules for you to teach. And of course, you can use them or not, but we're really happy to provide that information as well. When it comes to research, of course, data is scattered across systems formats in just all over the place. And part of research, of course, is finding the data, but hopefully with FME, you can spend less time fighting with the data and more time extracting the value out of the data. Could be just data preparation, getting the data ready for the analysis that you're going to be using. And also using FME, you don't have to be a programmer. Maybe if you're a data analyst, but oh, geez, I want to work with a bunch of data. Now I got to write a lot of code. Well, having to learn a programming skill in order to work with data it helps, but really it's nice if you can just access the data directly. And of course, one topic that's driving a lot today is Gen AI. And Gen AI is driven by data. And our whole thing is we want you to be able to use any AI, not just one AI. And I was at a talk at a health conference, and one of the speakers went up and said, the best way to get your value from AI is to give it all the data. And that's really what we are about. And in the world of data, AI is inseparable from data. And we're excited to make these tools available to students or educators. Because the last point there is you could just be a student doing isolated research, and you're still eligible to get form. Yeah. And so obviously the benefits are clear. The students can now really experiment with data and have fun seeing all the different things that they can do with data. No code, of course, lowers the bar. So you don't have to be a code jockey in order to access the data. Research, you can spend more time on the analysis, because that's what research is really about. It's not about fighting with data. It's about doing your research so you can, discover new insights, gain new understanding. And again, innovation, yeah, any AI is really what it's about. There's so many different AI platforms out there, and we're starting to see really specialized Gen AI tools that have been trained on some very private but really highly valuable data. So that's really exciting. And then, of course, it never hurts to learn a tool that's used in industry, so that when you do graduate or move on to graduate studies or wherever, you're really well equipped to work with data and solve data challenges. So, yeah. So FME, we're the only all data, any AI integration platform. There's some other platforms out there that have decided to have their own LLM, and then you have to train it, and maybe it's good, maybe it's not. But you just look at the proliferation of AI, Gen AI tools and Gen AI models out there. And really, you need a platform that can access any of them. And indeed, we have some clients who have used 3 to solve one problem. So that's really exciting. Yeah. And our platform's really simple. There's 2 major components. FME Form is where you build, the data transformations, where you build the AI workflows, and you can author in there. It's a no-code environment, so you can visualize it. You can also run it in there if you're just doing one-offs. And then there's FME Flow that enables you to take advantage of automations and really take it to the next level. You can do parallel and distributed processing in there. And of course, we have a SaaS version of FME Flow called FME Flow Hosted. One of the things we also really pride ourselves in is the unrivaled data support. And this is just a bubble representing the vast majority. We just recently added graph support. So there we go. So this diagram gets out of date about as fast as we build it. And so the point is, any kind of data you're working with, let us know, and we're happy to work with you on that. Yeah. And so now over to some real world cases. And the first person I'm going to introduce you to is Dr. Patrick Booth from the University of Wollongong. And the first thing he'll do is tell me if I pronounced it right. Okay, take it away, Patrick.
Okay, thanks, Don, for the opportunity to talk on behalf of the University of Wollongong today, and introducing how we use the FME grant licenses here at the University of Wollongong. So licenses, particularly for our undergraduate students, are used in a common 100 or first year level subject, which is the sustainability and engineering design. So this is a subject that's given or delivered to our cohort, our complete engineering cohort across the university in their first year. So it is a mandatory subject. And what we're trying to do is introduce students typically coming first year out of high school. So most of them do not have any experience in the real world yet with regards to the software tools that are commonly used in actual engineering design and engineering practice in industry. So our licenses here at the university are deployed on laboratory computers, where they can be shared with other tools such as ArcGIS Pro and Autodesk AutoCAD. And they're using those tools to essentially produce a design for a notional humanitarian project. So in addition to those undergraduate licenses that are deployed on the laboratory computers, we also have a number of licenses that are used by our postgraduate researchers, including myself. Just recently completed my PhD in mining from the University of Wollongong, and my research was in gas emissions from underground coal mining. And the FME licenses were instrumental in really integrating the various sources and indeed output formats that are commonly used across the mining industry. The beauty of FME in that regard is that it is platform agnostic. It doesn't really care what input format or what output format is desired. We can use both of those or any of those platforms that FME is capable of reading and writing to be able to display and analyze all of our research work. So by way of introduction, the 100 level subject for sustainability and design involves a community development supporting around about 300 at-risk Indigenous people. And from the screenshot, you can see there, we give the students a bounding box where they can place their community project. And in addition to site selection, they also produce conceptual level access, housing, power, water, and wastewater and facilities design, which is suitable for presentation and reporting to a national humanitarian international client. So they're getting exposure not just to the software tools, but also how to work in a multidisciplinary team. Typically, the students will take on those disciplines of engineering that they are actually studying. And because it's a combined compulsory subject at that 100 level, you see a great disparity in the input formats that are required for display and analysis in these designs, but also the need to display in the output form the various contributions of each of the engineering disciplines into that humanitarian project. So students are really encouraged to produce designs using the software tools, not just FME, but your AutoCAD and ArcGIS to an extent, and place those designs in the real world. And what that does is give them an introduction to some of those real fundamental GIS concepts through hands-on exercises that they are contributing to as part of a team. So some of those fundamental concepts include your coordinate systems. For those that are coming to us familiar with the Google Earth maps, WGS84 and similar lat long, where they're confronted with having to source data to support their designs, such as imagery or infrastructure that exists in these project sites, and having to relate those in a common coordinate system, combined with both vector and raster data. And they're confronted with having to do those basic clipping operations and spatial joins in order to visualize and analyze the information that's required in preliminary design. One thing for introduction, and I know other speakers will be talking to, digital elevation models in industry have become one of the first things that are required in front-end engineering design, isolation or elimination of totally unviable options. And to that extent, using the tools such as FME's ability to overlay imagery on a digital elevation model and then produce things like either a GLTF model for display in any common browser, or indeed back in Google Earth itself using the KML format that FME is capable of. The students can quickly identify that a site that they may have selected cannot be actually used because of access issues with steep gradients, or indeed if they've located too close to a river, for example, which may be subject to flooding during certain seasons. So all of these exercises give students a real practical introduction to skills that are commonly used in industry and very much in demand for their future careers. Okay, another example of how we've used FME is in display within the Power BI environment using the Mapbox visualization. So Mapbox vector and raster tiles can be written from FME and incorporated into the Mapbox style for use in the Mapbox visual within Power BI. So data from a simple Excel table with lat-long coordinates that display the various gas core samples that are shown as the points here within this video, they can be filtered and visualized directly within the Power BI report. And on the fly, relationships that are stored in the tabular data model within the Power BI environment can be visualized as shown on the screen, including the tooltips for display of that gas core data. There are several mapping visualization types that are available within the Power BI platform, but one of the most advanced types is the icon map, which is being produced by James Dales. That visual can accept data in the form of well-known text, which is increasingly a format of the geometry which is stored in SQL-based spatial databases and in Google BigQuery. So FME to the rescue again, and easily managing the extraction of the geometry in multiple different formats into that well-known text type for display in those videos as you see. Okay, another format that we use is the GLTF format, where various data visualization techniques have been used in a combination so that we can see in this example both the concentration of gases, the content of the gas core samples that have been used. Here, the extrusion or the height of the pillars represent the gas content, and the color represents the gas composition. Here on the screen, we can see the transition of the gas composition from green being almost 100% methane at the top right of the screen through to a almost 100% carbon dioxide environment in the left-hand side of the screen where the pillars transition to yellow to red. The black pillars represent recorded historical outburst incidents, and all of these pillars are overlaid over a surface representing the floor of the coal seam with vertical exaggeration, but the color and the shading representing the slope and the aspect from the calculation of the depth of cover that we've also done in FME. Another example I'd like to illustrate is our use of FME in mine safety research. So we're really leveraging the data integration capabilities of FME in some real cutting edge research into mine gas emissions and gas safety for underground mining. And some of the workflows that we've developed for research include production of high resolution digital elevation models and 3D exploration boreholes, in addition to some gas drainage boreholes. What we've identified through our research is that high resolution interpretation of particularly the depth of cover, which has a relationship to both the vertical and the horizontal stresses at the coal seam level, are really highly correlated to the probability that certain gas emissions may occur in particular locations and in particular seams of the underground mine. So FME was used for handling some really large data sets in terms of identifying exactly where things were in not just 2D space, where typically a lot of the mine plans and gas drainage designs were, but in addition, adding that third dimension at high resolution and using the base of the coal seam as a reference due to the geochronological order of the deposition of these sedimentary layers in the coal seam. It's quite easy to identify some of those common relationships at various points intra-seam with using the coal seam floor as a reference. So by creating digital elevation models of the coal seam surface using FME as the tools, and some of the transformers that I'm displaying there on the screen, such as particularly putting everything in a common coordinate system using and then clippers, we were able then to add a lot of different spatial properties such as slope and aspect and curvature and distance and vectors to various features such as faults or structures in the coal seam that really enhanced our insights into the correlations between those depth of cover and horizontal stress magnitudes and orientations. And what I've displayed in there was actually one of the transformers that was published to the Hub by our colleague Greg Patterson, who will be speaking later today, which is the aspect slope creator. So it's a version of a raster calculation that's actually used to represent visually both the orientation and gradient of particular features in the digital elevation model. And that's quite useful for displaying some of the information related to the horizontal stress magnitudes and orientations in the underground environment. So what our research has determined is that high resolution depth of cover, and particularly visualizing that with a slope aspect representation, it's critical to the fundamental calculations that are actually required for gas emission prediction. So in addition to that, we can demonstrate using the 3D polyline features where we've extracted historical records, typically paper copies of well logs for surface to inseam and beyond exploration boreholes. We've converted that using FME and combined all of these into both Excel spreadsheets, which can be referenced as tables from other data sources, but producing the 3D lines for visualization of not just the depth of particular exploration boreholes, but also the strata through which they are passing. So an example of how we've used FME to visualize the 3D exploration boreholes in combination with both a high resolution digital elevation model of the coal seam surface and also the surface here in the Aurora is shown there on the screen. You can see from the surface to seam boreholes, they do display in different colors the geology or the different strata that the exploration boreholes were passing through. And by producing both the surface and the underground different digital elevation models on the same common coordinate system, we're really able to see those relationships between the horizontal stress directions induced by that change in depth of cover, and also how those relate to the surface features here in the Aurora region. So just to conclude, we had FME used for both undergraduate and postgraduate research here at the University of Wollongong. And FME has been instrumental in introducing our undergraduate students to the various software tools that are available in industry. And in the postgraduate, really that democratization of the various sources and the various formats of data that FME is capable of translating and integrating together for common visualizations that are easy to share with multiple different organizations. All right, that about wraps me up, I think.
So thanks, Patrick. That was absolutely great. Fantastic to hear how you're using FME at your university. And next, I want to introduce Greg Patterson from RMIT University, or is it RMIT? And again, he can tell me the appropriate, but he's a teacher and an assessor at that university. He's going to talk about FME grant licenses there.
Thank you, Don. Yeah, it's RMIT. I'd like to introduce myself, Greg Patterson. I teach at RMIT University, and I've been teaching there for 6 years. I teach from the Certificate 4 in Surveying and Spatial through to Advanced Diploma. Now, when they finish the Advanced Diploma, students go into Geospatial, into Remote Sensing, or into a surveying program. So the students learn all about different software packages, and the main one I teach is FME. I teach students all about spatial data, the different formats, spatial references, and just to show you some of the examples I'm going to go through. This one here is where we have a boundary of Queensland, and the students get to have a look at the data sets. It's lines, so vector lines, and what they have to do is convert it into a polygon. From that, they then download any image they want and then add the image. So they actually build the workspaces in there. So in this case, got the lines, they fix up any errors. So there's gaps, there could be intersection errors and all that. And then they create a polygon from that. And then they add an image and then output it into different formats. So in this case, they put it out to a KML file. Also, we do mapping, and we get to play around with the different data sets and manipulating data. And this is an example of the diploma students creating some of the mapping products. So we had a theme pirate map, and they have to obtain the data sets from the councils. They download the different images from the web. They have to acknowledge where it came from. And then they produce the different maps. So here's a couple of examples on the right-hand side of the maps that they produced. I actually learn a lot from the students as well. So it's really cool. And in this case, they have transparent images, which is something I didn't know about, how to bring that in. And they actually taught me something. So it was great. And I'm always learning. They also learn about terrain visualization. So creating different products from DEMS, TINs, LiDAR. So from what I provide them, so we get the data from the council, which has been very helpful with our students. So we get a digital LiDAR. We produce a DEM. So I'll show them how to produce like a 20-meter DEM, 1-meter DEM, show them what happens when you produce at different sizes. And then from that, they produce hillshade, slopes, aspects. And the other one we do in there is created the aspect slope, and Tom Farrington helped me with putting that together. So I'd like to thank him for that one. And then what they do is they put that into a 3D model. So we get to play with that. This is an example of a 3D model. We took LiDAR, we created a tin from the LiDAR. We grabbed the image and overlay that. So there's only 3 transformers in this, and then outputting it into a 3D PDF. So it's pretty cool. It's a wow factor for the students to see how we can take LiDAR with not many points in there and then drape the imagery over the top where they can have a bit of a play around with that. Other things we do, we get into doing analysis work. So students get to learn about satellite imagery, being able to download different images such as red bands, red, green, blue, combine those together to create a color composite image. They also combine the infrared and red bands, and then they conduct NDVI. So in this exercise, they're looking for healthy vegetation, and then they go on to analyze the area as well. So there's a lot more involved, but it's all getting them ready to go on to the university where they can go into more studies on this. They, again, analyzing a lot of things they also get to learn. So it's all about learning the software and what you can do with the software at the end of the day. They produce a lot of graphs. We did a couple exercises where they work with categories. They're going to work out what's affecting the categories. They create a scatter plot. And they also a symmetry where they have to analyze the data, do some research, and find out what age they were when they passed away, what the different religions are, and all that. So it gets them to learn about creating graphs and all that using FME, and also being able to use a template. So they bring in a template and then actually output it, so it's actually produce a really nice product at the end. Again, analysing data. There's some survey data that's collected using some of the equipment, so GNSS, and for the students be able to manipulate it and process the data. So we go through Excel, show the students how to do that, and then they, after they've completed that, they then use FME to do exactly the same thing, and they get to understand the process. So doing it through Excel, they learn the process, then go back to FME, process it, and at the end of the day, they can output it into any format they want. This is my last slide here, but I just want to show the importance of all the training that I give the students. It's really cool when I see them not only going on to really good jobs that they get. So 90% of those students, or nearly all the students, get jobs in the surveying or spatial industry when they, even after they've started in the Cert 4. Now, when you teach students how to determine the shortest path between using road data set, and they can go between one section of road to another section, so it might be one side of Canberra to the other side, or Vancouver, one side to the other side, and then be able to take an image, so a black and white image, and convert that into a vector data, say a raster into a vector. And I had a student, Alan Hatcher, said, from working out the shortest path and then taking an image and converting that into vector data, I'm going to solve a maze. And he did. So he actually went that night, looked at those 2 different workspaces that we developed, and then created this maze. And I thought it was pretty cool. You can download this, it's online. You just take a maze and then you can actually just put it in there, change the background, whatever you want, run it, and it actually solves the maze. And I thought that was pretty cool, that when you can teach, and then they take it away and then they start playing with it. So I've been teaching the students for the past 12 years. I write a lot of programs as well, and I publish those on the hub. I send those through to Canada for them to look at as well. And it's all about teaching the students a lot of the transformers that I put together, say the aspect slope or the aspect. They're all published on the web, but the students don't just use that transformer, they have to actually build it from scratch. Anything we do, we go right back to the basics and get them to build it. And it's a lot of fun for the students. I think that's the last slide I have. So at the end of the day, I've been in this industry now 46 years. Going back when I joined the Air Force, so I was in the Air Force for 21 years, eventually became an imagery analyst, working with aerial photography. On completing that, I went to Geoscience Australia. I worked at doing topographic mapping and so on. So I've been in this industry, worked with mapping, worked with the councils and everything. But I found that with this product, in the 46 years I've been working, it has to be the best product I have ever used. You can manipulate anything. With the data set, you can read any format, or mostly every format, but you can output into any format you want. And to create an Adobe 3D PDF is fantastic. You can do it with these. And the best part is everything is documented for you. So you finish it, you can set up the whole thing, document every part of it. So it has to be the best product I've ever seen. And thank you very much. Hope you enjoyed that. I'll pass you over to Don. Thank you.
Okay. Yeah, so thanks for sharing that, Greg. Really exciting, and we really appreciate you taking the time to share with us how you're using FME with your instruction. And okay, one more. Okay, last but not least, I'm happy to introduce, we call him Sasha Stepanov. He officially goes by Alexander. So he's been a long time user of FME, and it's always great when I bump into Sasha at an FME show or an Esri UC or somewhere on the road. And yeah, so with that, I'll let you take it away, Sasha.
Good morning, everyone. Don, thank you for the introduction. My name is Sasha Alexander Stepanov. I work as GIS IT Manager for Administration Finance IT group for University of Massachusetts Amherst, and also I'm a adjunct faculty with GIS Technology program here at UMass. We're quite large university. I put some stats on the left side of the slide, but also it's interesting fact, Massachusetts being quite small state is home for more than 100 colleges and universities. So we're very education dense area. I have been teaching a course on spatial databases and data interoperability at UMass with GIS Technology program since 2019. Usually it's courses offered in the fall, and mainly we focus on two major aspects, is how to do geospatial computations and analysis on database level, and the second part is actually how to integrate the other systems from real world to that particular, let's say, database or system, and that is data interoperability issue. So the second part of the course is focused on data interoperability issues. So that term was coined in the end of 50s, when it was studies about what makes organization work or not. And then computer science people took this term and make it data interoperability. So the second part of the course is focused, and we use FME mainly as our major tool, how to connect any type of database to hundreds of other systems. Though, let's say, the first part of the class maybe sounds modern, in reality, if you check Michael Stonebreaker's, who is the father of all databases, talk, Turing Award lecture in 2015, where he describes his experience, he talks about extending a relational database management system with GIS functionality in 1985. So it's almost 40 years ago that was already idea implemented how to do geospatial in the databases. The students for this class, in my class, have coming from diverse disciplines, from geography department, planning, environmental, conservation studies, forestry, engineering, but also they have very different level of GIS and IT skills. In this program, we use 3 types of licenses. So we use individual licenses for students. They can get FME software for their desktops. We're also running about a classroom with about 40 workstations where we provide FME desktop software for students. And also I always bring to students' attention the ability to get postgraduate license for them and then bring it to their employer, use it for business consulting, for any type of use. Why, in my opinion, FME is effective teaching tool? So first of all, it offers natural learning curve, and again, taking into account that students have very different backgrounds and domain knowledge. And another part that Safe Software provides very efficient video trainings, which can be assigned as assignments. And another point why I really like to use FME for teaching and kind of exploring concepts is use it for exploratory data engineering. What I mean under that, there is this term of exploratory programming where there is kind of, this is a way where you have idea and then you start developing software, and at every step you can add something, inspect something, and be in constant reiteration. It's usually called as a REPL, read, evaluate, print loop. If we think about the current state of FME desktop, FME form, it actually presents that environment of exploration and interactive exploration for data science, data engineering, any type of geospatial workflows, because you have caching capability, so you don't need to read data all the time. You have capability of do data inspection at any point and do it in graphical form or in tabular form. Also, there is a detail inspector where you can do almost like surgical analysis of any component, and the data flow happens on the feature level versus, let's say, when we move the whole data sets. And ability to rerun or retest a part of our workflow at any time. And that makes FMEs a really wonderful exploration tool. Another part is we always highlight the feature of FME as self-documented workflows or environment. And in this case, it's easy to share, maintain, and support workflows with students because I can share, let's say, with them partial workflow with instruction and ask them to complete, let's say, the second or some portion of that workflow. And another part is easy to provide feedback when, for example, if students has a problem, they sending me question, I can open FME workflow or FME workflow template, immediately start analyzing their data sets, provide my comments or my corrections directly in the workflow and send them back. Another, again, extremely important point why FME is wonderful teaching tool is this abstraction, power of abstraction, particular readers and writers. Because in this case, students have opportunity to connect to more than 500 different systems, to write data to more than 400 data systems. But in reality, they need just to figure out how to do writer and reader, how to set and configure that up. Also, that hides all the complexity of authentication to modern systems. If it's ArcGIS Online, if it's Google environment, Azure, if it's other systems, FME really hides that complexity and removes the roadblock from students if they, for example, want to use that in environment. Students immediately can start working with complex databases, and the complexity of creating tables, setting attributes, indexes is actually hidden. For example, students get concept or ideas about how to use spatial SQL very quickly. And I found that one of the most intimidating steps is actually, okay, now I know how to use spatial database, how I can get data to that database. When we're using FME, it's really smooth and easy to use. Also, again, if you would like to extend it and if you would like to apply your programming skills, there is a Python and R integration transformers, and students can expand, let's say, their approach just from using these traditional transformers. And with time, it reinforces our motto in the class that it's important to be data-centric and format agnostic. And when you work with FME technology, after some period of time, I notice I stop asking about formats at all. I'm just asking about data quality, data integrity, data accuracy, but stopped worrying about formats because I know using FME I can move data from any system to any system. We have very good tradition in our class to start it with guest lecture and our dear friend Dmitry Ba from Safe Software, very kind to join our class sessions in first or second class meetings to give his lecture on what he's doing with FME technology. And why we do it directly in the first part of the class, just to give students idea what is possible, to open their horizon. And Dmitry does amazing job to demonstrating what is possible, because he's classically trained geographer, but his spectrum of projects, it's from analysis of natural language to computer vision to any type of augmented reality. 10 years ago, you have to have special focused education in this particular area of computer science, image analysis, etc. But now with FME, it's available and available for students to try. And I always put FME as a skill amplifier. Important part of our teaching approach is to have term project where we give opportunity for students to work on real world applications. And when we do that, we're looking for 4 major themes that it should be from A to Z, meaning it's from data sources to information, actionable information for stakeholders to decision makers. Then it should be part of system integration, meaning don't reinvent the bicycle. Take what works really well for these systems and combine them in very innovative way. For example, it can be a Google Forms, it can be ArcGIS Online, it can be another system combined through FME, and we have a complete solution. We talk about automation with attempt to minimize any type of manual work. We almost strive for build completely automated workflows. And finally, the big part of the term project is a reproducible research or reproducibility, meaning, and the question is, okay, what it will take for you to rebuild your analysis, redo your analysis, if let's say your study area is changed, if data were updated, etc., etc. And again, FME is a very natural environment to address these themes and communicate these themes. And now I would like to show some examples of student projects where, again, I will highlight some aspects of why I selected them. This is a project for doing baseball analytics by John. It's for 23. So he is a baseball fan and built a whole study which includes harvesting data from major baseball sites and getting all type of statistics, then calculating based on specific player capabilities and statistics, the angles and trajectory projectiles of hits when the ball is hit. Finally, he collected the whole subset of baseball stadiums walls and built that in also in FME. And finally, it was completely 3D analysis, a representation of baseball analytics. And in this case, John demonstrated ability to work with ArcGIS Online, different types of APIs, JSON libraries to create charts and graphs, also generate 3D objects, and everything is reproducible. Another project, which again, I would like to bring as an example of teaching with FME. Catherine did this analysis, building 3D urban buildings and also trees to do analysis of energy savings from trees if, let's say, they shade building from direct sun. Again, in this case, student demonstrated ability to work with Esri ArcGIS Online, any type of APIs, JSON, LiDAR, 3D libraries, etc. Here I would like to point on slide 2 and slide 3. So let's say we start with building this process diagram, a logic diagram with students, because it really outlines the whole project and workflow. The interesting fact that then you can convert or build this diagram in FME directly, right? It's almost one-on-one mapping. So your logical ideas and your implementation, they did not differ. In some cases, we do the following. We start building, let's say, a large idea with these blocks in FME on Canvas using the bookmarks and annotations. If students will start just feeling that or building that idea up. So again, it's a wonderful tool to explore ideas and build it, and also even do a little bit kind of doodle on the side. And FME Canvas, you can, let's say, disable some of the branches of FME transformers and start building a parallel one, just kind of musing about some ideas and do almost like a programming etude on that. This third example, it's again a project about data preparation for flood mapping. From my point of view, highlight was a student really built a practical case of downloading, retrieving very large data sets automatically and conducting analysis also in an automated manner. And in this case, John used a lot of raster analytics, which usually we don't do in FME in the class, but this was very, let's say, advanced example. And again, John started with no experience in programming or FME. And probably that concludes my overview of our use of FME licenses.
Awesome. Okay, and so now I'll invite Dawn back on the stage here.
Yeah, thank you so much, Sasha. That was great. And I look forward to Dimitri showing you what he's been doing with Gen AI as well, because Dimitri and I have been working a lot with that. And also with FME, we have a new AR solution coming out that's going to be revealed at the peak too. Lots of exciting things for Dimitri to show you and your students to have fun with. Yeah, great. Awesome. Okay. Yeah, so a little bit about Safe Software. We've been around for almost 31 years, so hard to believe. And you can see we have 25,000 customers from the very small to the very large. And we strive to be accessible to any organization, regardless of how small or how big they are. And around the world, 200,000 users. So amazing numbers for sure. So take it away, Elizabeth.
Sounds good. All right, so in terms of next steps, we would love to help you get started applying for your own grant. We do have an application hub surrounding the grant program, so we'd encourage you to take a look over at that page. And of course, highlighted today is our grants for both instruction and student use. I will also send out this link in the chat just so you have that handy. But yes, this is a great place, a great hub to get started and learn more with resources there. Once again, our Peak of Data Integration is coming up in Seattle this May 6th to 8th. So definitely take advantage of early bird pricing and we will see you all there. We do have a community badge to redeem today if you're a member of our FME community. I'll drop that in the chat now. This is a thank you for joining us today if you do participate in redeeming badges. If you aren't a member of the community, we'd encourage you to check it out. It's a great place to gain any solutions to your data integration challenges. All right, so in terms of resources, we're all about free resources here at SAFE. We have free instructor-led training, which is offered over at our academy. So academy.safe.com if you'd like to take advantage of that. And then also a shameless plug for our webinars. We have some great upcoming this new year. So take a look at that page and register now. All right, and with that, we do have some time remaining here for Q&A. And so we do have some popular frequently asked questions here that we can get to. I didn't see a ton others come in, but I'm just doing a final scan through the...
No, it's almost like people are thinking about other things this time of year. I don't know.
Yeah.
Big on people's minds. So yeah, anyway, it's really great. And really, you know, if in doubt, if you're not sure whether you qualify for the charitable, just ask. The worst thing, you know, we will say is no. But if you're associated with an education organization at all, just let us know. So because we really enjoy seeing what the students are doing with FME, and it's remarkable. It's you know, as good as any work we see, you know, anywhere. And you know, if you have an AI program, for example, and you want to get FME in there, because our tagline is all data, any AI, and we're having lots of discussions with all the vendors who build AI solutions. So yeah, so please do, you know, yeah. So
absolutely.
Yeah.
All right. Thanks for joining us as well, Shannon. Shannon runs our grant program, actually. Yeah. So excited to have her expertise on air at the end here to help us. We do have some FAQs that I've dropped in the questions tab. Okay. So does that sound good, team? Maybe we can
Yeah.
We can address those?
Yeah.
Okay. So just the first one here that we get sometimes, are student licenses available for personal use?
Yeah, I mean, if you're a student, then I would say use them for whatever you want, honestly, right? You know, so yeah, you're not going to be a student forever, and they're intended for educational use. But if you go, wow, this FME is really, really useful, and you're also volunteering to do sports or something, and you know, or whatever. I think the to be a student, your email has to be associated with institute. Isn't that how we tell? So if I'm going to say SFU, and the domain is sfu.ca, we at SAFE know that you will not have an sfu.ca email account for very long after you graduate. So that's the limit of the enforcement. Full transparency, we don't have time to police what the students are doing. And I was a student too. And so just have fun with it, have fun with data, and you know, don't worry. Once, you know, eventually you're going to either create a company, or you're going to go work at a company, or you're going to go on and do further research. And in all those cases, you will be able to, you know, get a license, whether it's through your company or for further research. So I don't know, I probably talked too long in that one.
I think you made that more complicated, Don.
I think I did. The answer is
yes.
Yes.
to a point, Don made a really good point though about make sure that you enter your student email address when you're applying, because that's a catch for us. For sure.
Yeah, that's right. And just ask to get more licenses. So if you're an instructor and you want more student licenses, literally just ask. Because often you might have a class of 300 people and everybody's going to need one, or, you know, and so, yeah, it's as simple as that. And it's form and flow. So it's, you know, so because flow obviously adds automation, it adds a whole bunch of things that form is where you create the workflows. Yeah. Yeah. How long are licenses valid for? That's a good question. I don't even know.
I can answer that one. We operate the instructor licenses the same as we do for our paid customers. So it's a 1-year license valid for 12 months, but they are renewable each year. So we do send out renewal notices about a month before the licenses expire. We just kind of ask, you know, how's it been going? What have you been working on? And it's really easy to renew. We get those done for you, and you'll get a confirmation email saying that they've been renewed.
Yeah.
Pretty easy.
Yeah. And we do love to hear the stories. Like we saw some of them today. So if you're a student or you're an instructor and something really creative is done, we love to promote that. It promotes you, it promotes your institution, and it promotes, you know, how people are creative with FME. So it's a win all around, right? It's good for the student. So it's good for everybody. So yeah. So yeah.
Okay, excellent. All right, well, that's it for our FAQs. We hope that those were helpful for some folks who might have had those questions as well here.
Great.
And I think that wraps us all up, unless the team has anything else before I conclude us here.
No, just thank everybody for their time. And thank you, Shannon and Elizabeth, for all the heavy lifting, and all our presenters, of course.
Yeah.
We know everybody's super busy, so really appreciate everybody spending the time. And yeah, and wish everybody out there, you know, happy holidays and a great new year. I can't believe we're like 2 weeks away.
I know.
So
yeah. Crazy. Merry Christmas, everyone, and thanks so much for joining us today.
And see everybody in 2025. Yeah.
Thank you, everybody.
Yep. Bye.
Bye for now.
Bye.